Welcome to the MSJC Internet Authoring Videocast.
Hello, and welcome to CSIS 113B, Java Programming Level 1. This is Lecture 1, Introduction to Java. What we'll be covering in this lecture will be basic computer concepts, how Java works, Java tools that you will need for this class, and then some anatomy of computer programs, specifically Java programs. So we start out with an overview of a computer and how it works. The hardware, as you're probably familiar with, consists of the central processing unit, or CPU, as well as memory, storage, and I/O devices. So I/O stands for input-output. Think of a keyboard as an input device and your monitor as an output device. So this concept of computer processing, known as IPO, is a process thereby where we input information into the system. The CPU processes that information and then generates some sort of output. Now that output could be just putting information into memory, as well as the input could also be retrieving information from memory. So the CPU is at the heart of all of the operations. So once the process has been produced by the CPU, as I say, it will then create some sort of output. Again, it may just be storing a value in memory, or it may be saving a file on a hard drive, or it may be putting output to your screen or some other device. So in programming, we focus on the memory and the processor because that's where the program exists. It starts out on some sort of a storage device, and when you activate the program, then all of the zeros and ones, the bits that make up that program, are loaded into memory. And then from memory, the CPU starts pulling in step by step each instruction from that program, places it on a particular type of memory called the stack, and then starts following those instructions in order. And as it's processing each instruction, it may need to retrieve more information from memory, or it may place new information on memory into memory. And in certain cases, that memory portion may be what's called the heap. So realize that the instructions are all in the CPU, or I should say the instructions being processed by the CPU come from the area of memory that's known as the stack. The stack will contain the instructions as well as variables that are the primitive types. You'll learn later on that there are essentially two groupings of variables. The value variables will be the ones that are stored on the stack. So those are known as value variables. Sometimes you'll hear them referred to as primitive variables. And then you have reference variables, or sometimes referred to as complex variables, and they get stored on the heap. So we'll deal with that a little bit later on. For now, just realize we're storing values into memory anytime that we define a variable. And then, of course, as the CPU reads those instructions, it's going to retrieve the values from either the heap or the stack as it needs. The CPU contains the instruction stack. It follows those instructions on the stack one by one in order, and then generates values or stores values into memory and retrieves them as needed. So here is an example of memory. And so we're kind of defining for you here the difference between bits, which is the zeros and the ones, and a byte, which is a collection of 8 bits. So that's how memory is addressed, is by bytes. They're grouped into bytes wherever they're stored, whether it be the stack or the heap. They're stored in bytes, and that's how they are referenced. You'll see that we don't deal with the lower level of memory reference when we're creating our Java programs. We're going to use named values. So we reference a name, and that's going to actually tell the processor what location in memory to go and find that value. We won't have to actually use the numeric values like you're seeing here, the addresses that the bytes are being stored into. The term bit is short for binary digit. A single bit can only be either a 0 or a 1, so it's either off or it's on. And then memory can hold program instructions, which we said earlier they are stored on the stack. And then data, again, that would be values that are not primitive values, will be stored on the heap. So continuing on with our discussion of memory, memory is organized then into these spaces as we've been talking about. So again, we have the program instructions in the stack, we have the program data, so the actual program itself is larger than what the stack can handle. So the program is in memory initially. It's being pulled out from memory as needed by the CPU and placed onto the stack as it needs to process different pieces of the program. And then there is a third area called the static area of memory where certain values and methods are stored as well. And we'll get into static values a little bit later on. So primarily your space is allocated for a program's instructions and one for its data. And the data space that is divided into those three areas: static, stack, and heap. The stack and the heap data is dynamically being loaded and removed. You know, it's important from a programmer standpoint that we don't try to place more data into memory than we have memory to be able to store that data. In fact, if we put data into memory and we fail to remove it, that can be referred to as a memory leak. And if you put too much onto the stack, you get what's called a stack overflow. So if you're working at a very low level programming language like assembly, you have to be very specific about when you're putting data into memory and removing the data that's not being used anymore from memory. When you're using a dynamic language like Java, it takes care of dynamically loading and removing the memory as is needed. Whereas our static values and our static methods, they'll exist for the life of the program, so it won't be until we terminate the program that those bits are actually removed from memory. So as far as the CPU is concerned, which is dealing specifically as far as the instructions are concerned with the stack, it has a program counter, it has instruction registers and a bunch of other registers, and there's also a component called the arithmetic logic unit, or ALU, and so that's where the mathematical processing occurs. So the size of the stack, the memory size of the stack, is based then on how many bits the CPU's registers can hold. And so in the early days we had 8-bit computers, and then we advanced to 16 bits and then 32 bits, and currently our computers can handle 64 bits. So that's the width of the stack, so that's how many bits that we can put per instruction into the CPU. Now this slide is showing you then kind of the overall structure of how applications interact with the operating system. So the operating system consists of these application programming interfaces, or APIs. And so the application will make calls to those APIs. The operating system then will actually use a software layer that's referred to as the HAL, or the hardware abstraction layer, and that's where we find the drivers that basically can translate between the operating system and the physical hardware itself. And so the operating system controls what calls can be made to the HAL. The HAL then will process those calls and pass them on to the appropriate hardware device. The hardware device does whatever it needs to do, and then the results of that get passed back up through the HAL, back to the operating system, and then back to the application that initiated the process to begin with. So as far as popular operating systems, you're probably familiar with these: Windows, Linux, Mac OS, Android, iOS. And some examples of applications would be things like a text editor or a compiler, which we'll talk about in just a bit. and a program, a custom program that perhaps we have written. So here we're taking a look at the Java compile and execute process. So realize that this is basically happening at that application layer that we were looking at here just a bit ago, right? So this is, we could be a program at number 1, number 2, or in this example, I guess we were using 3, right, is the program we wrote. So that's where our Java program is running. So that Java program is actually going to have another layer, which is in this graphic, you'll see it on the far right there, the JVM, or the Java Virtual Machine. And it's the Java Virtual Machine that will take what's called the bytecode of our Java program and then pass that to the operating system. So let's take a look at the whole process here. So we're going to write this Java program. We're going to get a source code editor. We're going to type out some code. And then that code needs to be compiled into what is known as bytecode. And so notice the extensions on these file names here. So our source code is going to have an extension of .java. So whatever you name the program, .java, that's your source code. And you'll always have to run that source code through a compiler. That's a piece of software that's able to take that source code and then convert it into what is known as bytecode. Some folks refer to it as assembly code. That bytecode has a file name of myprogram.class. So that's the actual file that gets activated and run on the computer. And again, because that bytecode is not in the format, the machine language that the computer CPU can process, we need another component, which is that Java Virtual Machine, to take that bytecode, convert it into the machine language, the actual zeros and ones that the CPU can process, and then pass it to the operating system, which then uses the HAL to pass it on to the CPU. So here we have another example of our operating system process using now the Java bytecode, and you can see it sits on top of the Java Virtual Machine. So that's JVM is an application itself, right? It's just another piece of software. So it's going to take our bytecode when activated, when the user double clicks on the program icon, or in the case of an iOS device or a tablet, you know, they're going to have a touch screen perhaps. However they activate our program, that's going to be our bytecode that is then sent to the Java Virtual Machine for conversion into the zeros and the ones, passed into the operating system, passed to the HAL, passed to the CPU. So when it comes to developing our Java programs, we'll follow these steps here. We'll write the Java instructions in a text file. That's our source code. And again, it is going to have a file that has an extension of .java, Java. Then we run that .java, that Java file, through the Java compiler. Now, if you're doing this from the command line, you can actually use Java C to activate the compiler, and then you pass the file name to that compiler, and it'll go through its process of creating the bytecode for us. And then once we have the bytecode, that's what we're going to actually run in the virtual machine, which again is another piece of software that's going to do the final translation. The reason we use this methodology is because back in the early days of programming, and in many cases this is still, many languages still only work this way, which is that when you write the source code, you would run it through a compiler that would actually generate the zeros and the ones, the machine language. The problem with that is the compiler is based on the CPU that source code was intended to run on, meaning that the output from the compiler would only work on a particular CPU and with a particular operating system. So in order for me to write a program that runs on multiple CPUs, multiple operating systems, multiple devices, I would have to do what was called porting that code. In other words, I'd have to write the source code for one system and then maybe tweak it a little bit and run it through another compiler for another system, and so we get all these different files, different machine language files that would only run on a specific system. So the Java Virtual Machine concept bypasses that or kind of fixes that problem. What the Java virtual machine is doing is that the folks now at Oracle, originally it was Sun Systems, but Oracle owns that company now or bought that company out. When that Java virtual machine concept was developed, the idea was that Sun, now Oracle, has a piece of software that is written to compile for the machine language for a specific CPU, specific operating system. So in other words, the Java virtual machine on a Mac computer is going to be able to take my code and convert it to the machine language needed for the Mac computer. The Java virtual machine that's running on a Windows computer is going to convert my bytecode into the machine language necessary for the Windows computer. And the same would be true for our iOS devices and our Android devices. So the Java virtual machine knows how to convert our bytecode into the proper machine language for each of the different operating systems and thereby CPUs that they're running on. So that makes it a lot easier for developers to be able to write the code once, create this bytecode that can now run on any device. And that was a big advancement really in computing. C# works the same way. They have an intermediary code language, and then they have a runtime that you can put onto any computer operating system now and actually process that intermediary language into the machine code necessary for the device that you want it to run on. So at this point, there is the Java language and the C# language, and then also JavaScript is similar. See, JavaScript is interpreted by the web browsers, and so the web browser for each different computer type is also converting the assembly code, the intermediary language, into the machine code that's necessary for the particular device. So Java, C#, JavaScript, they can all be written once and used, run everywhere. Now, as far as writing our source code, there's a lot of standalone tools out there. The idea or the difference between a standalone tool and an IDE is that the standalone tool, you have to have a lot of different components to, one is going to be the source code editor, and then you'll have a separate compiler, and then you got to buy, or not buy necessarily, but you have to get the software development kit for the specific language. That's basically a class library. So we'll get into classes here in a little bit, but the idea is that to help us developers not have to reinvent the wheel all the time, these languages are built with libraries of code that we can utilize in our programs to help simplify the writing of our programs. And we'll show you a little bit about that as we go along. So a standalone tool, you have to kind of get all those individual components together yourself and make it all work. Whereas in an IDE or an integrated development environment, all of those tools that are necessary are built into a single application, a single program. So it is helpful to know how to use those individual tools. That's how we did it in the old days, but IDEs really make our life a lot easier. So the tools that we'll need for this Java class will be NetBeans, which is an integrated development environment. It has the source code editor, it has the compiler, and then also it's bundled with the SDK, or actually they call it the JDK, the Java Development Kit. So that's the program that we recommend that you use. There are other choices. You have Eclipse, JEdit, IntelliJ. There's some links there for you if you want to use those, or if you're already familiar with them, then that's fine too. Go ahead and use those. And you'll encounter a lot of other possibilities out there. Just for our particular course, we selected one particular tool, and this one is developed by Oracle, and so it's kept up to date with the latest JDK that's out there. Now we'll take a look at an actual program itself. So getting away from the language that we're using necessarily, although we'll focus on it a little bit more here as we go through the rest of these slides. But generally speaking, when we're talking about a computer program, we're talking about writing designs that solve a problem. You've probably heard the term algorithms before. So an algorithm that's all it means is just basically a solution to a problem. And it can be written out just as a text format to begin with. And, eventually we have to get to some sort of source code that can be compiled, but there's all different kinds of formats that we can use to kind of think out the logic of how this program should be built before we get to actually writing that source code. So when we're talking about an algorithm, as I say, we're talking about designing a solution to a problem. But also an algorithm has a definition that the solution that we create needs to have well-ordered, unambiguous steps. So in other words, those steps can't be confusing, and then they have to occur in the right order. Those steps need to be effectively computable operations. So we'll have to learn what those computable operations are. We'll talk about statements and statement blocks and various types of ways of configuring our computable operations. When executed, they need to produce a result, and they also need to halt in a finite amount of time. And so later on we'll talk about getting into loops that do not end and basically create memory leaks or stack overflows. So some of the tools that we can use would be flowcharts. There's also a concept of pseudocode. So you kind of, we're just writing out what the steps are in a standard sentence format, English format, or whatever your language happens to be. But eventually we need to get to source code, because it's the source code in a particular language that needs to then be compiled into either machine code eventually, or an intermediary language in the case of Java and C# and JavaScript. So again, an algorithm needs to design a solution to a problem. It's going to be well-ordered, unambiguous steps, effectively computable operations, and when executed, it'll produce a result that halts in a finite amount of time. So here's an example of a flow chart just to kind of show you one way of thinking through the process. So you can see here that we have listed kind of the pseudocode on the left and then the flow chart on the right. And then also there's a group of symbols there right underneath of the title flowcharts, and those are just from the Microsoft Visio program. Those are the symbols that we use to indicate different components of the program. So rectangles represent a particular process, some sort of a procedural process. Diamonds represent decisions being made. Decisions are a common methodology that we need to incorporate into our programs. And then we've got ellipses to identify the start and the end of a program. We have trapezoids to represent our data. And in this one, we're not using any subprocess or any documentation. So you can see that this particular program starts at the top on the right. So that's, again, if you follow the steps on the left, that's the pseudocode that's identifying what we want to accomplish here. And then the flow chart is a visual representation of that. So here's step 1, where the program starts. Here's step 2 now, where we're taking input from the user, assigning it, in this case, to a variable named x. So that's going to be storing that information so that anytime we want to retrieve it, we just have to refer to x to get that value that was stored in there. Then the program takes the second input from the user and assigns it to y. So just a new variable name. We're going to call this one y to assign the second value to. And then our program is going to take those two values that have been input by the user and compare them one to the other. In this particular case, we're looking to see, is x greater than y? So that's the comparison that's being made here. And so if that comparison evaluates to true, then the value of x will be output to the screen, to a printed piece of paper, whatever the output device happens to be. The output will identify that x is the greater value. So that's if the comparison is true, or yes, as you see in the example of the flowchart. If the comparison is false, or no, as we see there in the flowchart, then y will be output as the greater value. And then the program finally halts in a finite manner, and that's the end of the program. Obviously a very simple, very basic program, but it does show you many of the concepts that you'll be utilizing as you develop your own programs. As you're writing your source code, you'll want to add some comments. Comments are a way of declaring what your intentions are with regards to your source code and placing it within the source code, so that when you go back later on and look at the source code, it'll help you to remind you of what the different pieces of code that you've written there, what their intention was, what you wanted to get accomplished with them. And then, you know, it could be that it's somebody else is reading your code at some point in time too, and so again, those comments will help them to understand why you wrote the code that you've written. So comments are code that are ignored by the compiler, so that means that it's not going, the comments won't end up in the bytecode at all. It's only in the source code. And we do encourage you to use comments liberally. Now you can use them too much, but it's just good to kind of succinctly define, you know, what's going on in each step of a program. So there's a couple of ways of inserting comments into a Java program. First of all, we could do 2 forward slashes. So if we just type in 2 forward slashes and then type something after it, that is a comment in a Java program. Everything after that double slash is the comment up to the end of the line. So as soon as we generate a new line feed there, the comment is ended, and now the interpreter, I should say the compiler, is going to be expecting some different kind of source code then at that point. Unless we add another set of, you know, double slashes, then we're adding another comment. So those are called single line comments. If you want to have a multi-line comment, then you would begin the comment with a forward slash followed by an asterisk. Now you can type as many lines of comment as you'd like, and then you have to terminate the comment with an asterisk forward slash. So just the reverse of how we started it. So the beginning starts with a forward slash asterisk, type in all the comments you want, and then asterisk forward slash, that's the end. So everything between those sets of characters, also known as tokens, will be considered a comment by the compiler. So here's an example of a multi-line comment, and this particular one is required for all of the assignments that you create in this class. So this should always be at the top of your source code. You're going to want to begin with the opening comment token, type in your name, your student ID, the date of when you created this assignment, what the assignment name is, and then a little description as to what the program is designed to do. So please make sure you put that in all of your assignments that you submit for scoring, because your score will be reduced by a point if you don't put a comment at the top. Now we take a look at the anatomy of a Java program. So these are some of the particulars that you need to remember as you're writing your Java source code. So first off, Java is a case-sensitive language. So if you write something that begins with a capital letter and the rest is all lowercase, that is the same way that you will need to represent it when you go to reference it within the source code. So usually it comes when you're creating variables or custom methods, because you're going to create your own names for those variables and your own names for those methods. And if you don't refer to them exactly the way that you wrote them, you know, by both case and spelling, then there'll be an error generated by the compiler. Java programs are comprised entirely of classes. So Java is an object-oriented language, and object-oriented languages organize their code into what are known as classes. You just want to think of classes as a blueprint. See, there's a concept in programming called DRY, D-R-Y, which stands for don't repeat yourself. So what we're trying to create then is reusable code. In other words, we write the code that solves a problem once. Now we can use that same code over and over again in different programs. You know, again, we're trying to simplify the programming process as much as possible. So the code that you will write is going to be organized into what is known as a class, and then as you get more and more of these classes built, those will be organized into what we call libraries. So in fact, that Java development kit, that's what it is comprised of, is these libraries that have hundreds, maybe thousands of classes in them that we can use within our programs. Some of the rules for classes: code cannot exist outside of a class. So what we'll show you is the format of a class is that you want to have the class designation and then the name of the class and then curly braces, an opening curly brace and then a closing curly brace, and everything in between all of that then will be the code for that particular class. Each Java file, so remember that's the source code files, they can only have then one public class within them. Now you can have private classes, protected classes. Generally speaking, you're going to find, at least in the course that we're going through here, Java Level 1, you'll just have one public class. Now another important thing is that each Java file name, so we're going to show you how to set up in NetBeans a new program, a new file, a new Java file. And what you'll see is that the file name that we create also becomes the name of the class then that we're going to be writing our source code in. So it's very important to understand that, because if you try to go back at a later date and you say, oh, I don't like that class name, let me just change that, it won't match the file name, and so when you go to run it through the compiler, you're going to get an error. So just make sure that the file name, whatever comes before the .java in your source code file, that name must be the exact same as the class name contained within that source code file. So now we get to the class header. So this is how you actually build the first bit of code. There'll be a little bit of you'll have a statement in there that it's actually going to be a package. So we were just talking about the classes grouped into libraries. So those libraries are groups of packages. Okay, so packages are classes grouped. You can have more than one class in a single package, whereas we said that you can only have one class in a single Java file, right? So it's kind of a hierarchical structure that you start building there as you get more classes into packages, and packages then can be built into or organized into libraries. So class headers then have, as far as the naming format goes, you'll start with what's called the access modifier. So public will be pretty much what you use in this class. In fact, every assignment in this class you'll have public as your modifier. Just know that you could change that. You could make it private. You could make it protected. You'll learn more about how to use those, when to use those when you get to the second level class. So after the word public, then you need the keyword class to identify to the compiler that, hey, here is the beginning of a new class, and then whatever name you call that class. And again, remember that that name needs to match the file name that the class is being saved into. Then you'll find that you have an open curly brace to indicate the beginning of the class and a closing curly brace to indicate the end of the class, and then all of the body of the class goes in between those curly braces. One of the things that you'll be adding in your class then will be methods. In fact, classes, when we get down to the component levels, have various member types. So we could have fields, which also you'll hear them referred to as properties. Just think of if I'm going to build a class called person, I might have a first name field and a last name field. And then later on, when we create an instance of that class, when we're actually running the program, we might want to assign, a person's first name to the first name field and the person's last name to the last name field. And that's one way that we store it into memory so that we can retrieve it when we need it. So just to think of fields as properties. They also represent states at certain, if you use them, utilize them in a particular way. So those are just values. Think of them as well, don't want to use the term variables here, because we can use variables in many different ways. But fields are properties. Like I say, a person class is a good example. Think of first name, last name as the fields or the properties. Methods are what are the actual activity, actual tasks that are being completed within the program. So just think of a method like a small program then within this larger program that is our class. So methods like the class has a header and a body. So in the method header, again, we have that access modifier, whether it's public, private, or protected. You'll be using public in all these assignments. Then you have to have what's called a return type. So since the method performs a task, a lot of times it's an operation where it's going to take maybe a couple of values that were passed into it and use those values to generate some sort of a result, and then we want to return that result back to the caller of our method. So if the method doesn't return a value, the return type is going to be void. If it does return a value, you'll have to identify what the type is. So we'll get to data types a little bit later on, but there's integers and floats and doubles and chars and strings. Those are all different data types. So if I'm going to put in two values like 2 plus 2, and I want to get the result of that, then it's going to return an integer. So I put int, which is how we represent the integer data type in our program. So whatever the data type is, that comes after the access modifier. If it doesn't return any value, we put void in there. And then it's followed by the method name and a set of parentheses. So the method name might be add 2 numbers. Then there'll be a set of parentheses, and within the parentheses we'll identify the what are called parameters, meaning values that can be passed into our method, and then those values will be used internally in our method for some sort of processing. And we'll get into much better detail as we get further down the road here for you. So that's the way that we identify the method, the access modifier, whether it returns a value, and if so, what type, its name, and then a set of parentheses, which could be empty or contain one or more parameters to identify what values and what type of values that can be sent into our method for processing. Then just like the class, then we have an open curly brace, a closed curly brace, and whatever the actual statements are then that make up that method will be in between that open and closing curly brace. So here's an example of a method that has to exist in our class in order for it to actually run properly. It's called the main method. Notice it is spelled all lowercase. Remember, JavaScript is case sensitive, so it's very important that the main method be lowercase in its spelling. And if you look at the graphic to the right there, you can actually see we've got 2 blocks being generated here. First of all, the outer block is the actual class itself. So you can see the access modifier there, public, followed by that keyword class, and then the name of the class, which is console. Then we have an opening curly brace. That's the beginning of our class. Within the class now, we have this method, what is called the main method. That's the one that always fires off first when our program begins running. So the method, the header for the method, has also the access modifier. In this case here, it's using the keyword static, and that particular keyword, when you're generating a method, that basically identifies that we can use that method without having to create an instance of our class. In pretty much everything we do in this course, you won't be making instances of your own classes, but we will be showing you that you'll be making instances of the classes that are available in the Java library so that you can use the Java library code within your programs. So just anytime you do main, just know it has to have static in there. If that doesn't make any sense to you at this point, don't worry about it. It really doesn't matter as long as you know to always put the keyword static in there. So it's going to be a public method, it's static, and it does not return any data type, so void keyword follows static. Then we have the method name, which again is main, all lowercase, and then you can see we have the parentheses, and in this case here, the main method will accept a single parameter. It is going to be a string array parameter, and we'll get to that particular data type and explain it in a bit. But just for now, know that that's just the data type is a string array. And then we have to name it because when we use it inside of our method, we have to have some name to represent that value that was passed into our method. In this particular case, we use args, A-R-G-S, and that's just a typical parameter name that's used for the main method. Now the main method has its body section delineated by an open curly brace and then a closing curly brace. And so everything that's going to happen within our main program, which your first programs that you create, your first assignments that you create in this class, will all occur within those curly braces. And then after the closing curly brace for the method, you see we have the closing curly brace for the class, the console class. So it's very important that you always encapsulate your methods inside of the classes that way. The class has to contain all of your code. Your main method will contain the bulk of your code, but you'll see later on that you'll create your own custom methods, and so you will have methods created outside of main but still inside of that class. And so that method you'll have to make sure is inside of that closing curly brace for the class. So as long as you keep track of those curly braces and understand and know correctly how to create those headers for the class and the methods, this should be a pretty easy class for you. So within our methods, you'll find that we have statements that are the instructions. The curly braces that we've been looking at, those are the blocks. So when we have multiple statements within our method, that's the method's block of code. And we have other structures that we'll be using internally within our methods as well that'll have blocks of code. So just realize that blocks are just multiple lines of statements. It's important to know, though, when you create your statements, that in order for them to be a valid statement, they're going to need to be terminated by a semicolon. So you'll get a compiler error if you don't end a Java statement with a semicolon. Now that's different than these blocks that we're looking at. Anytime you're dealing with curly braces, you don't put a semicolon at the end of the curly braces. It's only the individual statements that go inside of those curly braces that you'll put a semicolon in there. Now one of the things that does for us is it actually allows us to write multiple lines of code and have spaces between those lines of code and not confuse the compiler, because the compiler always just looks for that semicolon. So you could have a very long statement that maybe you want to put on separate lines to make it a little bit clearer, easier to read. That's okay. As long as you only have the one semicolon that ends the entire statement, then the compiler will understand it completely and not have a problem. So there's a few examples there of some simple statements. One, we're declaring an integer variable named x, and it's being assigned a value of 3. So notice then the semicolon to end that statement. Or another statement there is an import statement. In this case, we're identifying one of the Java classes that we want to use within our program. And so in this case here, within the Java library and its utility sublibrary or package, we want to use the scanner class. And that's using a format known as the dot notation. And notice that the class name begins with a capital letter. So all your class names should begin with a capital letter. So when you're creating your own classes, you want to follow that format. That way it makes it easier to recognize a class versus a library. Now the next one, you'll notice it begins with a capital letter, system.out.println. So what I just stated to you earlier is true. Class names begin with a capital letter. So within the system class, which is actually part of the java.language package, that particular class is always available to you and the compiler when you go to compile your program. So whereas previously we had to import the scanner class, which is used to take input from different sources, the keyboard generally is what we use in this class. That one we have to import because it's not immediately available to us, but the system class is, and so anything from system we can just use immediately with our program without using an import statement. So again, scanner is a class. In this case, we're looking at system now. It's a class, and then it's using the dot notation to point to the print line method that is within that class. So I won't get into out, which is an instance of the print string type. So system, just realize, is a class. It begins with a capital letter there. In this particular case, we're using its out.println method. And what that does is it basically will print text to the screen, to the display. And as long as we put it in a pair of double quotes, you want to use double quotes for your string output. And whatever text we have between those quotes, that's what gets outputted to the screen. And then again, this is a single statement, so notice that it ends with a semicolon. So those are individual statements, and then blocks will be things like classes, methods. We'll get into decision blocks, like if and else if statements, iteration blocks, which are for loops and do while loops and all that kind of good stuff. Those all utilize blocks, meaning you're going to start with a curly brace, you're going to create a header, then have an opening curly brace, closing curly brace, and then put statements in between those curly braces. So never terminate a block with a semicolon. Those are terminated. They're delineated by an opening curly brace and a closing curly brace. That's it. So as we saw in the last slide there, if we want to generate console output in Java, we just use either print or print line. We showed you print line in the previous example. Print is also an option. And the main difference between those two particular methods are that print will generate a single line of text but not generate a line feed, whereas print ln stands for print line, meaning it'll generate a line of text and then also generate a line feed, meaning moving the cursor down to the next line. So just take a look at that. You can see that it is in the same format as we saw on the previous screen. So system class.out.println method, in parentheses and in quotes, the string of text that we want to display on the screen. And it is a single statement, so we want to end it with a semicolon at the end. Here's an example of writing our first program. The class name in this particular example is my first. So notice that does begin with a capital letter, my first. The same format we've been talking about. You got your access modifier, keyword class, and then the name of the class. Then open curly brace, and then inside of the set of curly braces, the open and close curly braces for the class, there we have our main method. Again, access modifier, keyword static, keyword void because it doesn't return anything, and then the name, which is all lowercase main. So class names capitalized, method names not capitalized. And then in parentheses, the standard string array with the name arguments assigned to that data type. So that's our method header, and then inside the method, or generating the blocks section for the method, again, open and close curly braces, has a single statement inside of it, a system out.println, in this case generating hello space world exclamation point within the quotes, within the parentheses, and then ending the statement with a semicolon. Then we close up the method with a closed curly brace, close up the class with the last closed curly brace. The term literals, you'll hear that from time to time. Literals just mean that they are the values, essentially, the values that are literally stated. So the examples would be a number 1 would be an integer literal, a whole number, whereas 2.2 would be a floating point literal. Has a decimal point in it. Even 0.3, another example of a floating point, also example of a literal floating point. Now the next two are interesting. If you take a look at the quotes that we're using there, for the first example, just the letter H has single quotes, and that's because that's how you indicate what's called a char, C-H-A-R, short for character, a char literal. So that means that we want to actually represent that as a single character, as opposed to the next example where we use the double quotes like we saw in the previous outputs that we were generating there. the word hello. So now we have multiple characters, which is referred to as a string literal. So a string is actually a collection of char values, and whenever you want to indicate a string, you want to make sure you do it within double quotes. If you only want to represent a single character, a char, then you make sure you do it in single quotes. So then the next bullet point just identifies, it's not legal to have single quotes. If you're going to have multiple characters, you can't put single quotes around it. That'll throw a compiler error. So just make sure that you understand that an H with single quotes is different from an H with double quotes. Two different data types. H with single quotes is a char. H with double quotes is a string. So chars go on the stack and strings go on the heap. So obviously that's an important difference as far as the compiler is concerned and the CPU is concerned. And we'll give you more detail on that in Lecture 2. Now, when you format your code, just realize that Java is what they call a free-form language, meaning white space is ignored by the compiler. So again, if you have long statements, you can actually put that statement, break it up into multiple lines, and the compiler will still see it as a single statement as long as you terminate the very last bit of it with a semicolon. Remember, the blocks go into braces. So here's some examples here, which is we're actually generating the main method here with a single statement inside of it, which prints out the word hi. So that whole line for that second bullet point, public static void main, parentheses, string array args, then notice we have open curly, close curly, and then the statement system.out.println in parentheses, in double quotes, hi, and there's that critical semicolon, and then we close up the end of the main with the closing curly brace. So that's a legitimate main method that could be written into a class. The next example is just as legitimate. Again, we start out with our public static void, but then notice we move to the next line with the word main, and then there's a bunch of spaces there before the parentheses, followed by the string array data type, and then on the next line is the name that's being assigned to that string array, which is args, and then there's the closing parentheses, and then further to the right you see the opening curly brace, system.out.println on the next line with the open parentheses. Then on the next line you've got in the quotes, we've got hi, and then the next line you've got the closing parentheses. There's the critical semicolon to indicate the end of the statement, and then right below that is the critical closing curly brace to indicate the end of the main method. So as long as you have those components and you understand that the curlies are for the blocks and the semicolons are for the statements, you should do okay. Of course, you wouldn't want to write it that way in most cases. You want to write it as clearly as possible. Now, you cannot use white spaces between parts of a token. So a token is one or more characters with a single meaning. So the examples that we use here, as previously we were talking about, if you want to use comments, you need a / asterisk, or to close the comment, the multi-line comments, it's an asterisk /. So you wouldn't be able to put spaces between the / and the commas there. The asterisks, that would throw an error. Same thing with the keyword if, which is going to be used for decision statements later on. You couldn't put I space F. That would throw an error as well. So those are referred to as the tokens, and keywords is another way to refer to the word if. And just you've always got to write those without any spaces in them. Another example below, static int. So int is how we are defining the return value of a method. We're saying now that this method main is going to return an integer value. Int is a keyword as well. You can't put a space in there. So you couldn't do that for static. You couldn't put a space in the word static. And even main itself, you can't put a space in the word main. But as we saw earlier, between main and then the open parentheses, you could have a space or multiple spaces, but visually that would not read very well, so we don't encourage it. You cannot put a new line in a literal string. So once you create a string, remember, which is using double quotes there, you don't want to have multiple spaces or even generate a line feed between the beginning of the In this case, I guess that'd be a phrase or a sentence. So that's just, it's going to basically throw an error at that point. In fact, that doesn't have an ending semicolon either, so that's definitely illegal. Now, the last example is legal, and that's because they're using a process, what is known as concatenation here. So we've started the string portion inside of the parentheses, but notice that it is actually a complete string, meaning we have the open double quotes and we have a pair of closing quotes around the but this. Then we put the spacing in. Then we use what is called a concatenation operator there, which is the plus symbol, meaning combine this with the previous string. And then we have another string, which is the characters inside of the double quotes there again. Now this particular example, though, if you look at it closely, it would actually not print out what you think it would. And I have in the red text there the actual output that you would see. It would read, but this is, there'd be no space between the this and the is, and then space legal. So in order for that to be correct, as far as visually, if you want to have a space in there, you'd have to have in the first string, but this, you could add a space before the closing quote, or in the second string, if you added a space before the word is, so after the first closing or the opening quote, you could put a space in there and then the word is, because that's going to be a literal value right at that point, and so that's how the output will treat it. If you put a space in there, it'll go ahead and include the space in the output, but it only reads the space if it's inside of the quotes. Any space outside of the quotes will be ignored. So then you must use white spaces to separate some tokens. So in this case here, the first bulleted point, when you take a look at it, you can see that the header is not formatted correctly. It reads static space int main with no space in between. So there the compiler doesn't know the difference between whether you're trying to identify the return type as an int or if you are just simply trying to name it int main. So we definitely need to have a space between the return type int and then the name of the method main. On the second bullet point, the system out print line, we've seen that previously. That's okay as long as we're putting dots in there. That is what we call dot notation, and that is the correct format. We're identifying, in this case, a particular method in a particular class, and then that method, whatever it does, is where we're passing in the parameter here, the text string, to that print line method, and it uses that information to generate the output to the screen. So we covered a lot in this initial lecture. We talked about basic computer concepts, how the input process output or IPO works in a computer. We talked specifically about how Java works and how we use the Java virtual machine to convert our bytecode into the necessary machine language for the system that we're going to run our program on. We looked at the Java tools that are needed for the class. We need a source code editor, a compiler, and the Java SDK, or JDK as they call it. And again, NetBeans would be the preference there. We talked about the anatomy of our computer programs. We talked about algorithms and flowcharts, and then specifically the anatomy of our Java programs. So we talked about the fact that Java is case sensitive, compiler, how it ignores white spaces. We talked about blocks being delineated by curly braces, statements being terminated by semicolons. We talked about the format of methods, how they have a header and a body. We also talked about classes, how they have a header and a body. We talked a little bit about literals, meaning the actual values, and then some discussion about formatting your code. So that's the end of Lecture 1. Until our next lecture, happy coding. If you liked this video, please click the like button and leave us a comment down below. I also would appreciate it if you would subscribe to our YouTube channel. Also, click the notification bell so that you'll be notified when new videos are posted.